So it says remember to save changes made to IceStaff, which I've done. Create a new form or a program that will allow IceZone to implement the algorithm you designed as a part of question 4. So in my previous videos, I've pseudocoded this already, and I'm going to produce it now. So we need to input the temperature, and if the value is 100, the message displayed should be program terminated. Output the appropriate message for the temperature input as shown in the table. So I've got to make this, and then we've got to store the last temperature in a text file called iceresult.txt, and then confirm storage of the last temperature to the screen, to the disk on screen, and then it says retrieve the last temperature from the disk. Right, okay, 12 marks for this. So let's get on with doing this. We'll come back to the exam paper because we're going to need to keep referencing this. And the first thing I want to do is get the temperature off the user. That's it. No more, no less. Let's get the temperature off the user. So I'm going to go to my 2019 solution where it's blank, and I know this IceStaff stuff is working, so I'm going to copy it all. Yes, I'm going to copy it all. Now you're going to need good knowledge of the code here in order to do this. I won't lie to you, because all we're doing is I'm just going to use their code against them. All right. So save staff. Well, I know later on I'm going to have to save some kind of temperature, right? And I'll leave that there. I'll leave everything the same as it is so far. Count staff. I don't need to count staff, do I? I'm going to have to... So I'm going to say, okay, that's saving. Confirm. Retrieve. Right, okay, I'm going to retrieve it. Right? Retrieve. Let's copy that. Back over here. Lowercase. Retrieve temp. Okay. That's going to be my procedure for retrieving it. And the only reason I'm doing that on there is because when we did the count technically retrieved the user details. So, okay, I'll keep that there. Make window is fine. Not going to need all these variables though anymore. I'm going to have one variable. I'm going to call it temperature. Right. There's my window, gets created. Here's my frames. I've got a label, and it's not going to say it's IceStaff. It's not going to call it IceStaff. I'm going to call it temperature checker. Leave that as it is. It's not staff ID anymore. It's going to be temperature staff ID var. No. This should be temperature var actually. Let's do that. Then I'm going to, yeah. Temperature var. Okay. So far, all that's happened is I've got a label on my graphic user interface. That's just the title, says temperature checker. I've got another label there that says temperature. Then I've got an entry box, which will be here. I'll call that temperature, not temperature var this time, just temperature. And that's the name that's assigned to the entry box. And then it's text variable, so the value inside it is going to be temperature var. Now it can be tricky to get your head around that, right? Just be careful. So think of the temperature var as the actual data itself. Think of the temperature as the object. Staff ID, it's not staff ID, it's temperature. All right, and that's going to be row 1, column 1, sticky west. So sticky closer to the left-hand side, if that makes sense. First name, surname, and postcode. I'm not going to need that anymore. I think I'll need one box. Then I've got button 1, button 2, which is save. Are we saving? Yes, we are. But the first thing I'm going to do, leave that as save temp, not count anymore. It'll be retrieve temp. Gonna need another one as well, because I think there's 3 things that I'm gonna have to do in here, and that would be B2, B3, and this one is going to check the temp. Now I don't have a procedure for that yet, so let's just make one up. Let's call it check temp. Save staff. It's not called save staff anymore. I'm trying to think what it was called. Save temp maybe. And then this one was not that one. Retrieve temp. What was it? Yeah, retrieve temp. Just check that one above there. Yeah, save temp, retrieve temp. Okay. So these commands need to match the names of the subroutines that you're going to use for them. So when I click the button, it runs the command, which is the code for that button. I'll put that down there. I'm going to pack this button in, so I need to pack B3 in as well, so that you can actually see it on the screen. Because if you don't do it, you won't see it. Pack it left and return win. That's fine. Run the program. Let's see what we've done. Right, that was very quick, I understand. I'm trying to keep this video short as possible, really. So this one here now is running the wrong version because, again, I've not gone back. So I'm going to right-click my solution in the Solution Explorer and set that as the startup file. Okay, temp check is not defined, which, to be fair, it isn't, is it? Def check temp bracket bracket. Now I'm doing this, obviously Python runs in a sequential order, so top to bottom. So I need to make sure that the subroutine is above the call for that subroutine. Otherwise, it's going to cause us problems. Let's take this message box here. Doesn't like it because I've got no code in there, so I'm just going to put some random code in there. I'll do. Okay. This is just to see if it will work and run, see what I've got so far. So I need to design my graphic user interface. Okay, good. Right. So I've got a temperature in there. So in the future, I'm going to type in something and then I'm going to click these buttons and it's going to do some stuff. So now let's do the stuff part. And I said to you, I want the user to be able to input the temperature. So to input the temperature, remember what my global variable is. Temperature. Temperature value, temperature val, or something like that. Or probably a better name for it would be current temp. And we're going to say equals temperature var. Now that temperature var there, that is a global variable accessible in all subroutines. And the only reason it's available in all subroutines is because I've declared it in the make window part here. So when I use or create this temperature var, you can see down here, the value inside the input box is called temperature var. That's why I'm using it here. And use the .get feature, okay, and that will then produce it to your screen. If you want to test this out and print it, by all means, be my guest. It's always good to make sure that you've got what you think you've got before moving on. So I'm going to run this check temp thing here, and I'm going to put a value in. 23, check temp, it says 23. This box pops up. No problem. So that's good. That means I'm retrieving the temperature. That's good so far. Now, when you get the temperature, you might want to think about handling the input of some kind. So I might say, all right, well, if you're going to bring in the temperature, I'm going to have to do some if statements on this in a second. So I need to make sure that this is going to be the right value. So if we're dealing with temperatures, we're going to have decimal values, aren't we? So I'm going to try to convert it to decimal values, because we don't know what the user is going to enter. If they enter something that's not a decimal or float value, then I'm going to produce this message box here, and it's going to say, and let's do an error one actually, let's do an error box. There we go. So message box.show error. It'll say error, please enter something to count. We want to say incorrect input detected, right? Then if it works in the float part, in the try section, if it works and it can be converted to a float, then we'll start our if statements down here. So we're going to say things like, if the current temp is equal to 100, what did it want us to do in the exam question? If the value is 100, the message displayed should be program terminated. Okay, so if someone enters 100, we're going to show, not an error, show info. I'll show you the difference between these in a second. Put that there. Instead of saying string, I'll say temperature checker. In there, I'll say program. Program terminated. Right. Let's just run that and see what happens here. Okay. I enter a value, a rogue value, right? Check it. Incorrect input. Okay, good. Letters. What if I enter blank? Nope, don't like it either. That's good. What about a number? 2? Nothing happens. Good. So if I put in 100, program terminated. Yeah? So if it equals 100, we're going to terminate the program. So far, so good. Now, in the question, it says here, output the appropriate messages for the temperature input as shown in the table. So I need to expand my if statements now to match my pseudocode that I did in question 4 and also match what's in this table here. So if the temperature is above minus 2.1, too high, between minus 2.1 and 4, then it's suitable for general skating, competition skating, ice hockey, and then there's a fault detected. So I'm going to quickly put in the rest of the logic for this, and I won't bore you typing it all out, so I'll just do it quickly and then come back. Okay, so here you go. I've put in there, I've got my conditions, so equal to 100, greater than minus 2.1, less than or equal to minus 2.1, and greater than or equal to 4, etc. All the outputs are all provided as per the table. That is job done, in my opinion. So if you want to, pause the video, have a look at it, type it in on your side, see what you think. Does it work? Probably does. Now, it's always important to just give it a test and make sure that you are doing something, it actually works and meets these conditions. It can be quite confusing when you try and do greater than or less than with minus numbers and things like that. So let's go for this range here, suitable for ice hockey, minus 5.6 and minus 9. So if I go something like minus 8, minus 8.0 should be, check that, suitable for ice hockey. So I'm, fine. What if I go do something like minus 4.1? Check that. Yeah, competition skating, okay. And what about minus 10? That's, fault detected. Good, right? No problem. So I'm happy with that. I think it works. No problem. Next step now is I move on, and it says store the last temperature on disk in a text file called iceresult.txt. So what I need to do is go to the save temperature. I'm going to butcher their code and make it work for me. Now, before I had this little try except block here, so I'll use that again actually, because I don't want them just clicking the save button and then it not working, or them trying to save a letter, for example. They can only save floating point numbers. So current temp in there, fault detected. Right. I've already got the current temperature. I don't need that. I don't need any of those because that's just retrieving information. I need the file handling. I'll tab that inside there, inside the else block. and it's not staff.txt anymore. It gave me a specific name. They called it iceresult.txt. So I'll just copy that, paste it in, delete some of those, right? Then it says, what do you want to write? Staff's ID save, first name. No, I don't want any of that. I just want to save the current temp. That is it. And then it closes the file, right? Job done. Run this. Get up my files actually. So these are my files so far. And I'll put in there minus 3.1, right? Check the temperature, yeah, general ice skating, click save, save, right? Oh, Mr. T off. Uh-oh. Try again. Okay, minus 3.1. Check it again, general skating, save the temp. Oh, now it's broken. Oh, what's it saying now? Write argument must be string, not float. Okay, I've converted it to a floating point number to make sure that that's what they enter. When I write it to a file though, I need to turn it back into a string because you can only write strings into a file. So there we go. Try again. Third time lucky, second time, third time, fifth time. I'll get it right one day. Save the temperature. Right, done. And you'll see ice result has now appeared. Double click ice result and you'll see it says minus 3.1. Okay, come along again, minus 4.5, right? Save the temp. Click on ice result again. What is going on? It's saving multiple. I only want one to be saved because that's what the question, if you read into the question, it says store the last temperature on disk. Not all of them, just the last one. So why is it doing that? And it's just because of the append mode. If I change that to write, it will overwrite anything in that file. So currently, I've got minus 3.1 and minus 4.5. Now I'm going to put minus 1.5 in there. Save it. Ice result, minus 1.5. Good. Change it again. Minus 5.6. Save. Reopen it. There you go. Good. Excellent. And the next thing I need to do now, back in the exam paper, is confirm the storage of the last temperature to disk on the screen. That is very straightforward because I've already done lots of outputs to the screen. I can show, I take one of these up here, I'll just whack that in there and it won't say temperature checker, it'll say temperature saved we have saved your last temp. So now it'll just output a box that says temperature saved. That's it. That's all they're asking for. The code has already been provided for you. I'm just going to manipulate it. Save the temp. There you go. Thank you very much. Job done. Right. What's the next thing? Retrieve last temperature from disk. Okay. Retrieve last temperature. Right. Now then, to retrieve the last temperature, I don't need any of this. Do I need any of this? No, 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 no. Okay, oh, this, I might need some of this stuff. Right, firstly, I don't need the variables and I don't need to get any information. I'm not counting anything, so I don't need any of that. I don't need any of the count again, so I'll get rid of that. Okay, we're going to try to open not staff.txt, it's called ice. Is it ice result? Yeah, ice result.txt, and we open it in read mode. Okay, if we can't open it, if we can't find it, then it'll produce an error saying error, no file to be read. Then the else part, we need to read the line. Don't need any of that. I don't need any of that. Keep the return there. Don't like that because it's not indented properly. Okay. Leave their variable name. So record var is given the value of file object.readLine. So it's going to read the single line from the text file. It's going to close the file, and then all I need to say is I'll put last temp, and instead of string staff count, I can put in there record var. Now, if I stored it as a string, it should already be a string anyway. So I could just do that, get rid of the extra bracket. Let's see if it actually does that. What is the last thing in ICE result now? It's minus 6.5. Okay, so if it retrieves minus 6.5, it's job done. Oh, would you look at that, people? Would you look at that? And that's it. So I've done that now. Back to my program, retrieved. Right, got all 12 marks. I've got all 12 marks plus the 4 for fixing the code. And all I've done, I haven't even written in my own code really. I've just understood theirs and tweaked it. And that's it really. Now, I'll break this up just like I broke up before. I'll break this up into a third part of me annotating and explaining as I go. And that will get us our last lot of marks. So this is 8 marks using the internal facility of the IDE. Add annotation to your code from question 5CII that would clearly explain the design of your program to another software developer. Save your annotations in the same file as 5CII above. So let's do that in the next video.